In the last video, we looked at elasticity. Now we are going to take a look at Hooke's law, which relates to the elasticity of an object. Hooke's law tells us that the ratio of the force applied to an object to its change in length is constant so long as the elastic limit has not been exceeded. Our equation looks like this. K is our spring constant, and that is equal to the force divided by the change in length. Remember, the triangle is the capital Greek letter delta, which means change in. We can also look at the equation circle for this equation. We have force on top and K and delta L on the bottom. As a side note, Robert Hooke first stated this law in 1660. Let's take a look at Hooke's law in pictures. As more force is applied or added to the spring is stretched longer. If K stays the same, that means we are using the same spring. Then, as the force increases, so does the change in length. This change in length is proportional to the amount of force, or weight, added to the spring. Let's take a look at example 2, which is an application of Hooke's law. A force of 5 newtons is applied to a spring whose elastic constant K equals 0.250 newtons per centimeter. Find the change in length. In order to find the change in length, we need to find an equation for change in length. Covering up delta L on the equation circle, we see it is equal to force divided by K. We can then substitute in what we know. We know the force is 5 newtons, and we know K is 0.250 newtons per centimeter. Dividing, this gives us a change in length of 20 centimeters. This concludes our discussion of solids and Hooke's law.